Hello guys, this is Sorkron from ITVation. Let's solve today a problem. In front of you there is a problem. Uh, there are some 5 videos which I have earlier uploaded, but video quality was very poor. So this is one of the problems which I uploaded earlier also. But these videos are not in my channel currently basically. So let's solve this problem once again. In my new videos, right? Okay, fine. So it is given a PXE, a polynomial of least degree with leading coefficient 1 and rational coefficients such that P of this expression equals 0. Then we have to demonstrate, check which options are correct, right? Fine. So let us consider root 5 plus of root 5 plus so on infinite is equals to alpha. So this value will be automatically alpha, right? So what we can write as alpha square is equals to alpha plus 5. That implies alpha is a root of this equation. Alpha is root alpha is root of this equation, right? Fine. So and we have to basically p of alpha equals to 0. That implies alpha is root of this polynomial, right? And this is also a polynomial whose root is alpha. That implies we can claim whose leading coefficient is 1, right? So we can claim p alpha square minus alpha minus 5 is none other than p alpha. Fine. And it has been said to be the least degree, right? So when we have the least degree, if it will, if let's imagine it has been said it is a degree of basically a 3 degree, right? So we can multiply linear factor, that is alpha minus k, and multiplied by alpha square minus alpha minus 5, right? But for the minimization of the degree, we should restrict our expression to this term only, because this term effectively has a root alpha, and we can't break it further, right? And if it is given, it is a 3 degree polynomial and something like that. Basically, minimal is not given, and those degrees should be mentioned. So we can also multiply alpha minus k factor, fine. And we have to, and for the value of value of the k, some additional information should be given, right? Fine. So what we can do is we can say p alpha is alpha square minus alpha minus 5. Let us proceed with the options. And let us evaluate option C and D first, then we will move on further. So it is given 0 to 1 dx upon px plus x plus 6. So it is 0 to 1 dx upon px is x square minus x minus 5 plus x plus 6. That is x got nullified. Dx upon x square plus 1. Dx upon x square plus 1 from integration limit 0 to 1. It will be tan inverse of x from 0 to 1, and that is pi by 4. Right? So this option is correct. Let us check the option D first. 1 to 2 dx upon square root of px plus x plus 4. तो ये हो जाएगा x square minus x minus 5 plus x plus 4, right? So we got 1 से 2 dx upon square root of x square minus 1. Well, there is a direct formula of this expression also. That is ln ln of x plus the square root of x square minus 1 from 1 to 2. That is ln of 2 plus root 3 minus ln of 1. That is 0. That is basically that is ln of 2 plus root 3. If you don't memorize this formula, we can derive also or dx upon square root of x square minus 1 from 1 to 2. Let us put x equals secant theta. So theta limits will be 0 to pi by 3, right? And dx will be equal sec theta, tan theta, d theta, and sec square minus 1 square, that is tan theta, so it will nullify. So we got sec theta d theta upon 0 to pi by 3. We got ln of sec theta plus tan theta from integration limit 0 to pi by 3. We got ln of 2 plus root 3 minus ln of 1, that is 0, right? So from this it is given ln of 2 minus root 3, so it is wrong. Let's check the further options. So it is given 100, r is equals to 200, 1 upon r square minus r minus 5 plus 5, right? Let's check it once, r square, okay. So it is given 100 multiplied by r is equals to 2, 200, 1 upon r into r minus 1, r minus of r minus. So it is 100, 1 upon r minus 1 minus 1 upon r, and the limits is between 2 and 100. Okay, so what we can do is 100, 1 minus 1 by 2, 1 by 2 minus 1 by 3, and so on, 1 by 99 minus 1 upon 100. Fine, we have put 100, right? So we got 100 into 99 by 100, that is 90. It is also correct. Let's check the option number B, PR plus 3. Okay, 1 upon r square minus r minus 5 plus 3, right? So we got r square minus of r minus 2. R is equals to 3 to 100, 100 probably, or what it is. It is infinite. Okay, so let mark it n and limit and approaches infinite. So it will be r minus 2 into r plus 1. So what we can do, we can multiply with the difference, right? So it will be r plus 1 minus r plus 1 minus of r minus 2. Integration limit r is equals to 3 to n and limit n approaches infinite. So 1 upon r minus 2 minus of 1 upon r plus 1, 1 upon 3. इस पे थोड़ी सी बात करते हैं, ठीक है? तो यहाँ पे क्या कर सकते हैं, 1 अपॉन r माइनस 2 माइनस ऑफ 1 अपॉन r प्लस, यहाँ पे देखिए 1 अपॉन r माइनस 2 माइनस 1 अपॉन r माइनस 1 प्लस 1 अपॉन r माइनस 1 माइनस 1 अपॉन r प्लस 1 अपॉन r minus 1 by r plus 1. Treat a different, treat as a difference, right? So put r equals 3. So 1 minus 1 by 2, 1 by 2 minus 1 by 3, and so on, right? Put r equals 3. So 1 by 2 minus 1 by 3, 1 by 3 minus 1 by 4. R equals 3. So we got 1 by 3 minus 1 by 4, 1 by 4 minus 1 by 5, and so on. So ऐसे ऐसे नलिफाई होते चला जाएगा. So we got 1 plus 1 by 2 plus 1 by 3. Fine. Okay. तो इसकी वैल्यू कितनी आ रही है? 1 plus 1 by 2 plus 1 by 3. इनफिनाइट वाला जो टर्म होगा वो उसमें 1 अपॉन करके होगा तो वो 0 हो जाएगा into 1 upon 3, and that is 5 by 6 plus 1, 11 by 6. 11 by 6 into 1 by 3, that is 11 upon 8. Let's take the option. It is also given 11 upon 18. So I hope you enjoyed this problem. This is a pretty good problem, which I have also uploaded earlier, but that video has been deleted because of poor quality. I hope you enjoyed this. Thank you.